Hello everybody, welcome to the screencast for Milestone 3 deployment presented to you by Team Trilith. The first task of the milestone is the ability to do configuration management via some tool. We would be using Ansible for this process. Also, we would be using a DigitalOcean droplet as the production server. So we ran a script which would basically create a DigitalOcean droplet. It would then create the inventory file, and Ansible would run the playbook by using the inventory file and the configuration.yml file, which would deploy all the dependencies on the production server. This is the prod configuration.yml file, which would install dependencies like Node.js, npm, forever, unzip, Python, and etc. We would require all of these things for our Node.js app. You can now see that the DigitalOcean droplet has now been up and the Ansible playbook has started deploying all the dependencies as a part of the tasks. So as you can see, all the dependencies are installed as a part of configuration management by Ansible. So this is the first task. We would now proceed to the second task of deploying the changes to the production server once the build is successful. We are using Jenkins as the build server for this task, and we would show that the build would fail on either test failures or on analysis failures. And for the Node.js app that we have used, we are using PMD analysis. We have created a simple Node.js app which would basically print out simple hello world statements to the user. We would now show a case where the build would fail when we change the test case. We've created a Jenkins job to track the local Git repo, and the build would be triggered using the hook. Also, if the build fails, the hook would detect it and it would revert back to the previous stable commit. So as you can see that the build was a failure because of the test changes, and we can see that in the logs. So there was a difference in the expected message and the actual test message. We would now pass the test case, but we would fail the analysis by introducing lack of braces in the code, which would be tracked by PMD. So it is still fetching the build status from the Jenkins job. The Jenkins job has failed, and this is due to the PMD warning of lack of braces, which is not recommended. We would now try to pass the build, since there would be no test errors and no check style errors. The build has triggered in Jenkins, and we would wait for the status. So the build has finished successfully, and now the user will be prompted to do a git push. Once the user does a git push, the changes would be pushed to Git as well as to the production server that we just created in the first step. So we're using Ansible to copy all the changes to the production server. So all the changes that are made to the local to the app in the local repo would be pushed to the Git repo as well as to the production server via the Ansible. So you can see the message that the changes have been deployed. We should now be able to access the production server, and the app is running at the port 3000. So this is the home page for the app, which is running on the port 3000, and this is the basic app for Milestone 3. We would now proceed to task 3, which would be using feature flags that are provided by the global Redis store to toggle the functionality of a task in production server. We are using the global Redis store, and we have used another DigitalOcean droplet for the same. The IP for that server is given in the config file, in the JSON file, and we have a JavaScript code which would enable the user to toggle the functionality, toggle the value of the feature, and the same would be accessible in the production server to give you access to a functionality of setting tokens and getting tokens. So by default, we have enabled the feature and we have set the token using /setRequest, which can be obtained by using /get. This token would expire in 10 seconds. We can now toggle the value of the feature by going to /featureRequest. So the feature for set and get has been disabled, which can be accessible in the production server as well. So if you now try to do a set request, you can see that the user cannot try to set a key or even get the value of a key. So this is how the global Redis store feature flags would be used for toggling the features, which would be handled from the local, localhost. We would now proceed to the fourth task of monitoring metrics on the production server. We are monitoring the CPU utilization and memory utilization, for which the threshold values are 60 and 30 respectively. They are being monitored using Python scripts. We have configured SMTP as the email server to send notification as soon as the values exceed the threshold. We would now start the monitoring script. Currently, the values are below threshold and hence no emails would be received. We would now start stress testing of our production server to increase the load. So in the command of top, we can see that both the CPU utilization and memory utilization are displayed. So the CPU utilization is much above the threshold and the memory utilization keeps fluctuating. So we've received email notifications indicating that there's a high CPU usage of 100% and a high memory usage of around 66%, which was the last email that we received. We would now proceed to task 5. The first step is to show a canary release, and we have created another branch called the canary branch for this purpose. We would now slightly modify the home page message and introduce canary keyword inside the home page and modify the tests accordingly. We are now adding all the changes and issuing a git commit. So the post commit hook has started. It is fetching the build status from the Jenkins job. Once the build has completed successfully, the user can push the changes to the canary branch and to the canary server. The canary server is a replica of the production server and has been created using the same script. Also, monitoring has been set up and SMTP server has been configured on the canary server. So now it is pushing all the changes to branch canary, and using the Ansible playbook it is deploying the changes to canary server. We've also created another proxy server using a DigitalOcean droplet. The proxy server would route 1/4 of the request to the canary server and remaining 3/4 to the proxy to the actual server. This is the home page of the canary server. We would now show how the proxy server would route the requests. So this is a proxy server, and we have configured an HTTP proxy at port 80. So all the requests at the proxy server would be routed in the ratio of 25% and 75% to the canary server and the production server respectively. So the first request is sent to the production server, and the second request and third request would also go to the production server. The fourth request is being sent to the canary homepage. So the changes which we had deployed in as we saw, those can be viewed inside the fourth request. So every fourth request would route to the canary's homepage. We have also started monitoring in the background, and if an alert gets raised, a value would be stored in the Redis global store, and the same value would be fetched to route the requests. So if the value has been set, that is the threshold has exceeded, the request will not be forwarded to the canary server. It would instead be routed to the actual production server from the proxy server. So we've now introduced a stress test, and after the stress test is introduced, we would get an email. So this was the previous email that we received, that the CPU utilization is above 100%. And after this, the canary server will not be accessible from the proxy server. So even if we keep clicking, we won't be able to go to the canary homepage, but we would be navigated or redirected from the proxy to the actual production server. Thank you.